Welcome to the Biomimicry lecture series. In this introductory lecture, you will learn about the framework and the practice of biomimicry and bio-inspired innovation and design. Biomimicry is a transdisciplinary process, design process, innovation process. We also call it biomimicry thinking. And it is based on the mantra of life creates conditions conducive to life. I'm going to say it again. Life creates conditions conducive to life. Transdisciplinary because it needs a variety of disciplines involved in the process. So you will always have biology or ecology involved and also design. So the design process, actually the thinking that designers do in order to solve problems. And another discipline or a series of disciplines that have to do with the problem that we're trying to solve. There are three essential elements to biomimicry. There's reconnect, emulate, and ethos. So let's look at those three. Reconnect basically means, as the word says, we reconnect to nature. And that means we are learning from nature in nature. And it helps a lot to have a biologist or an ecologist be part of this introduction or practice in nature. Emulate means to mimic nature, and there's particular biomimicry process that we use for that. And it can be approached from two different sides. We could either come from biology to design, and that means that somebody's out in nature, noticing something about how nature works, and then takes an idea that they found there and applies it to their practice, whatever it is, technology or social innovation, something that they've been thinking about, and when they see a trigger in nature, they use it for their work. Or you could be coming to this with a particular design challenge already in your mind, and then look for particular functions that would solve that issue in nature. And that is a very choreographed process that I'll be talking about next. The four phases of this choreographed process is scoping, discovering, creating, and evaluating. So let's look at what they look like. This is a picture of a scoping process where we want to know how is it that the problem got created? What is the context? What is the system in which this design challenge arises as a problem? And in the picture you can see a process that is called design thinking. We use it for a variety of human-centered innovation processes. And it looks like this. A lot of people working in what might look like chaos, but it's really an organized way of thinking in a creative way through a problem. And so you see Post-it notes on walls, and ideas get reorganized many times before clarity comes to the surface. And it is clarity that we're looking here for. So we want to know, how is this design challenge created? Why is it a design challenge? What is the context in which it arises as a problem? And who are the stakeholders that are part of this dynamic? And then at the very end of the scoping process, we want to have a function question. And function question just means that we want to ask, what is my design supposed to do in the end? And the focus here is on the to do, the verb that would describe the action that a design is supposed to have, the impact it's supposed to have in the environment. This is important because we are not looking for a one-to-one relationship in nature, and not a direct correlation. We're actually looking for the strategies that nature uses to make life happen again and again. That's an important thing to track, because in all other processes, design processes, that would not be the case necessarily. Here it is a practice that requires that you look for the function. The second phase, discovering, then takes that function and biologizes it. By biologizing, we mean it gets transferred into a language that you might find in a biology book, or that you could tell to a biologist or an ecologist and they would understand what you're asking. Each discipline has their own language, own vocabulary, and is blind to all the others. So the task for a biomimicry designer is to make these, help with these translations. So we first go from scoping from the human world to nature, and then we go from nature back to the design world. So in this case, at the beginning of the discovering phase, we are looking to biologize the function into a biology research question. And that research question would then ask, hey nature, how are you doing this function? Who or what is doing this function? And then we look basically with the help of a biologist at the design table, or an ecologist or a naturalist. We look then which organisms in nature perform that function. And then we find most likely a bunch of them. And by organisms we mean plants and animals and humans, anything, any process that's an organic process. So then we're going to find some of these organisms, and these organisms then each have a particular strategy. So we're looking for multiple organisms, and then we're looking for the strategies of all those multiple organisms, and then we see the pattern maybe that nature is using to solve a particular issue that pertains to life. And sometimes you find a champion, so one organism does exactly what you want to do. That's rather rare. So we look for a multitude of organisms. We're going to look at how they perform that function. We're looking at the strategies to perform that function. And then we also look at the details of that strategy, the particular mechanism of the strategy. Once we understand all that, then we take that mechanism and translate it back into the design world, and we call that abstracting design principles. So we take something that might not even be called a design principle, and then language it so that designers at the design table can use it directly to solve their problem. Another way of saying what is an abstracted design principle, it's a design criteria. And all design challenges, all design problems have criteria when you move towards the solution. The third phase is called creating. Creating is a series of brainstorming techniques to come up with with concepts. And then those concepts get further and further refined, like you might know it from any design process. So first you have a lot of ideas, a lot of concepts, and then you filter it through, you develop it further, and eventually you come out with one or a handful of solutions that you want to consider further for a prototype. The picture that you see here shows a process that we call kinesthetic modeling, where we actually use objects just because that stimulates our brain in a particular way that other ways don't do. So we actually use a variety of brainstorming methods to come up with the concepts, and then the usual design process that you know for refining these concepts into prototypes. The fourth phase in biomimicry is called evaluating. And evaluating simply says we're looking at our prototype and see, does it meet the design principles? There's something specific about biomimicry in these design criteria that we want to meet, and that is the sustainability mandate. I will be talking about this later in the lecture. So let's think about what kind of innovations or what kind of designs are we talking about when we talk about biomimicry. And we can categorize them into forms, processes, and systems. Nature actually really likes to use form. So in biomimicry we say in biomimicry we say form is cheap, because whenever you can solve a problem with a different shape where you don't have to add energy into a process or into running a system, you get most out of it with the least effort. So form is always the one that is easiest fulfilled. Here's an example of a form solution, a bio-inspired form solution. In this case, it's a biology to design product that we're looking at, the Spinanker, or spin anchor in English. And it came about by somebody, an engineer, who noticed a tree and the roots of a tree. And many trees, not all of them, but many trees have a very widespread root system, sometimes many times bigger than even the crown of the tree that we can see. And this root system, of course, has the task of mining and harvesting nutrients and then filtering it through to the branches and the leaves. But it also has the function of keeping that tree rooted in earth. So when a strong wind comes by, it won't fall over or anything like that. And so this engineer looked at it and thought, that could be used for anchoring big constructions to the ground. And in fact, that's what it is. A spin anchor actually holds a house or a ski lift part down into the ground without having to seal the soil surface. And that's a big deal now in sustainability, right? So we want to keep the ground active, we want to keep the microorganisms active, we don't want to disturb the surface. And so this is a very important innovation that I hope will take off more, even more than it has already. And it is, as you can see in the picture, it is these tree root-like structures that you screw into the ground and you just put your surface, your house on top of that without having to build a concrete foundation. So that's an example of form. So in here we emulated the form of the roots in the ground to have the same function. And the function here is to keep the structure in place. Good. Another form example, the Vitalis water bottle. And here the intention was to reduce, so the function was to reduce the amount of plastics that needs to be used in order to make this particular shape of a bottle, water bottle in this case. And the champion, so this is really a champion, one kind of a tree that they used as a sample from nature, a structure, so again a form that has the function of being able to withstand lots of pressure from the environment. So in this case it's a tree maybe on a rock in a very windy place at the ocean maybe or something like that, and it grew so that it twisted. So in this twist it actually made a very strong structure, stronger than if the fibers were just going vertically as they usually might do. And then this was emulated into a bottle that is 100% already using recycled plastics. And it was designed to have this particular shape so that the molecules of the material is twisting in this way, which makes it very strong, but you can use a lot less plastic. So that was the function here. Another form example. So let's look at an example that shows us all three: form, process, and system. There's a company called Interface. They make modular systems for flooring, carpets basically. And they started with biomimicry many years ago. They were some of the first pioneers. They were the first pioneers that brought biomimicry to their own business and really were very successful with it. So they invited the biomimicry folks. Janine Benyus, one of the co-founders of biomimicry, came to them. They were at that time in Georgia, in the US, and they asked a question to nature. Hey nature, how do you do flooring? And so they went out into the forest in the fall, so you actually saw many different colored leaves, and they walked around in the forest with this question in mind. And they noticed that in nature, particularly when you see lots of leaves on the ground, you would notice that they have different colors, different shapes, different sizes. They weren't uniform at all. But as a whole, they still made a very harmonious flooring. And that's what they were after. And at the time, it might be interesting to know that what people did then for carpeting was they did this wall-to-wall carpet, which had a challenge in terms of keeping the color even. And so it was revolutionary to do a carpet that was, first of all, cut into tiles, not a whole thing. And on top of that, those tiles had different colors. That made it easier to exchange the tiles when you spilled something or they got ruined in some other way. And also it solved the problem of the color, and it made a really cool design. So they were very successful, and then they wanted to continue with the process of asking nature, what else could we do? What else could we learn from you, nature? And they started to replace some of their materials. Materials that had to do with the fibers, as well as the materials of the foundation, this rubbery material, and then also the materials that you use to glue down the carpet to the ground. So now we go to a sample of process. And you see here a gecko. A gecko was the starting point, because a gecko hangs from the ceiling against gravity, and they used it in order to solve the question of how nature keeps things on the ground without, or on a surface, without having to use a glue. And at the time, they couldn't solve the problem that we didn't have enough fine-tuned machinery, electronic material to notice that they actually don't have a glue on their fingers or paws, but they have this little fine hair that create an electric charge, lots of fine hair, then that electric charge actually keeps them to the ceiling, keeps them stuck to the ceiling. But it brought them still to the question of, hey, do we really need to create something against gravity? So then they remembered that gravity is already working for them. When you put down tiles, the tiles wouldn't be flying anywhere else, they would just lay on the ground, but they couldn't figure out how to make them stuck nicely, neatly towards each other. So then they developed this thing that's called tactiles, but it is a tiny self-adhesive piece that is stuck to all four corners. So if you have four tiles together like this, right? So if you put this tactile on the four corners in the back, they would actually stick to each other. So they don't necessarily get glued to the ground, not at all. They stick to each other. So then when you have all the tiles stuck to each other, the carpet is quite heavy and just lays by gravity on the ground without having to use any glue. Yeah, that also was revolutionary, because glue is a material that has lots of formaldehyde in it, and that was really that still is the biggest issue with all this material, non-natural material that we have in our housing, is the off-gassing, and that we breathe in, that are chemical substances that we don't want to have in our bodies. And so then they solved how we lay down, and they solved that we don't need any more glue. And then they just kept thinking about, well, what else could we do? Then they revolutionized how they work with each other, so how they organize their daily work, and how they work with their stakeholders, so people who buy their carpet and deliverables. And they just kept working. They got really excited, and now we're looking at a system. So you see the picture here of an ocean, and now they are actually using old fishing nets as the main raw material for creating new carpet. Most likely they'll also shred some old carpet into it, but they're using the old fishing nets, and they're solving a problem for the environment, in that they have made a business deal with these people that live in these fishing villages, where in the past, when a net breaks, they just leave it in the ocean and don't bother with it, but now they collect it and put it together and sell it back to the company. So they sell it to Interface, and Interface uses that material as an ingredient in their raw material list. And so they have actually gone from form, got excited about the whole thing, to process, and then to whole system. And so this is a stellar example of a company that works towards sustainable futures. And they use the biomimicry process to get there. Let's look at another amazing company, Kohler, and they make sanitary facilities. Kohler actually has an Austrian root with the original owner, but it's an American company. And in the United States is very well known. Every household knows who or what Kohler is. Most likely they have some of their stuff, tiles, faucets, bathtubs, toilets, things like that, and kitchen material. And so here we look at Kohler Waste Lab. And this is also an innovation from design challenge to biology. And this was developed by a biomimicry person, so someone who was trained in biomimicry. And she was asking, Teresa was asking, well, we have all this waste in the production. So not even the waste that comes back to Kohler, but the waste that is created in the production of these sanitary facilities. And so they were like, in nature there's no waste. In nature everything lives in a circle. So whatever is waste for some organisms is food for others. And nature breaks down the materials again into the basic components, and then those basic components make new life. And that's what they emulated here, mimicked here. So they have figured out a process where they have to figure out a way how to separate the materials again. So they have pure raw materials. And then they have to figure out how to put them back together so they perform in the way they need to perform. And then also the glaze, like how can we make a glaze that is non-toxic, that's very challenging, engineering-wise very challenging to do. And the example that you see here is this beautiful glaze that looks like it's breaking, but that's actually became a design feature in it. So this is also an example of a company that has huge impact, right? So if they figure this out and a lot of people get into it, then the whole story of sustainability can grow and really impact everyday life. We call this upcycling waste into luxury products. And so they keep working on this and they'll improve the process, and you get very beautiful tiles from that you can feel good about. So now we've looked at some really nice examples of biomimicry and bio-inspired innovation. We've looked at form, process, and system, and we have shown you some successful companies that have really taken off because of biomimicry. Now let's look at another essential element called ethos. And ethos is another word for the philosophy of biomimicry, the foundation why biomimicry exists. And here at this point, I would like to explain a little bit about the difference between bionics, biomimetics, and biomimicry, and maybe some other bio-inspired processes that you might have heard of. Biomimicry, amongst all these, is the only one that has a sustainability mandate. And this is the distinguishing factor for biomimicry, because bionics and biomimetics, they have processes attached to how we come up with the ideas. They have pulled together a bunch of design thinking processes in their own formula, but they do not have a sustainability mandate. And it came about because it's a rather old idea to look to nature. So bionics and biomimetics are older than biomimicry, and it was developed by engineers, so electrical engineers for bionics and mechanical engineers for biomimetics. And at the time, sustainability wasn't a big thing then. And so the people today that are using the bionics process or the biomimetics process, they may or may not include sustainability depending on what their other intentions are. But for biomimicry, there's the 26 life principles. They are really the base of it all. And if in biomimicry you do not adhere to these 26 life principles, then you cannot call it a biomimicry innovation. So that's a really important distinction. And in this ethos, in this philosophy, we say in biomimicry, it must be sustainable. It must lead to sustainable futures in the way nature does. Because we know that nature creates conditions conducive to life. And that's what we should be emulating as humans. Why? Because we are part of a very integrate complex system where organisms work together to make life happen. So if we don't take care of these other organisms, that they have a good life, so to speak, if we don't take care of our environment in which we live, that we also depend on, then we're probably not going to make it. And so therefore, this adherence to how nature works, the patterns that nature uses to survive and to thrive, are at the bottom of everything in biomimicry. So these 26 life principles are organized in 6 master principles and 20 sub-principles that are organized according to these 6 main principles. For instance, adapt to changing conditions is a master life principle. So is be locally attuned and responsive, use life-friendly chemistry, be resource efficient in material and energy, integrate development with growth, and evolve to survive. So in this video, we introduced you to bio-inspired design and innovation, to the framework and the practice of biomimicry. We talked about forms, processes, systems. We talked about the 4 phases of scoping, discovering, creating, and evaluating. And we talked about the sustainability mandate embodied in the 26 life principles. And now we will tell you more about each of the 26 life principles by showing you how nature creates conditions conducive to life.